The concept of pressure is force applied divided by the area where the force is applied, okay? So this is going to be force 2 divided by the area 2. Okay, so the idea of force tells you that you need to write there any number that has Newton. But here, you're looking for this force, so this one is going to be unknown. The force applied in the small piston. So your unknown is going to be the force 1, okay? That is going to be your unknown, what you have to find. So force 1, you can isolate already for the first one. Okay, this one is dividing here. So when you pass it to the other side, we'll be doing a multiplication, okay? So this gives you force 1 equals force 2 divided by area 2 times the area 1. That is the formula that you have to use. But let's say if we have the data enough to make it. The force 2, I don't know it, okay? The force 2 should be here, but I don't know it. I just know that the car is 2,000 kilograms. So in order to get the first 2, I have to apply the concept of weight. So force 2 is going to be equal to the weight of the car, and it's equal to mass times gravity. This is 2,000 kilograms times 9.81 meters over second squared. How much is this? How much is this? And tell me the units, please.
19,620.
19,620. And it's
In
going to
newtons,
be
right, Miss?
newtons. That is correct. So you have already the force. Now we need to get the areas because I didn't give you the areas. I just gave you the diameter. So we're going to apply the concepts, the formulas that we apply in continuity to get the areas. The pistons have circular shape, okay? The area 1 is the small piston. And is a circular shape, okay? So that means that you have to get the area of a circle. So it is pi times the radius 1 raised to the second power. That is the formula that you have to use to get the area 1, okay? Now let's work with the diameter. I'm going to work with the diameter here. Diameter 1 is equal to 4 inches. So I'm going to write it, and I'm going to do the conversion factor. To what number is equal 1 meter? How many inches are in 1 meter? How many inches are in 1 meter?
39.37 inches.
39.37 inches that you have in 1 meter. Cancel and cancel. How much is this? Remember 4 digits after the decimal.
0.1016.
0.1016.
1016, that is correct. These are meters. That's the diameter 1, And with this, you get the radius 1. So it's going to be 0.1016 divided by 2. That is 0.0508 meters. Okay?
0.0508.
Exactly. I'm going to move this. Okay. Now that you work with the first diameter, you work with the second one. Second diameter equals 20 inches. 20 inches I convert to meters, okay, with the same conversion factor. How much is this?
0.5080.
0.5080. Cancel the units. Okay, this is the diameter, so you need to get the radius. The radius of the section 2, the large piston, is going to be half of what you got. How much is that?
0.2540.
0.2540.
That is correct. Now, knowing the radius, okay, you can get these areas. So we're gonna get area 1, which is the small piston. So you have the formula, pi radius 1 to the second power. So this is pi times the radius 1, that is 0.0508 meters to the second power. How much is this?
Means it is 0.00081.
0.0081.
Okay, that is correct, 0081. And remember to write square meters. Now let's get the area 2. That is the large piston. Okay, so the area 2 is equal to pi, the radius 2 raised to the second power. This is equal to pi times 0.2540 meters raised to the second power. This gives me
2027.
0.2027 rounded. Okay. Now you have the two areas and you have the force, so you can apply Pascal's principle. Okay. So I'm going to number the steps. Okay. Step 1, step 2, step 3. Now in the step 4, I'm just going to apply Pascal's. Okay. So I'm just going to copy this part. We apply Pascal's principle. We say that the pressure both sides of the hydraulic lift is equal. Wait. And then we isolate for the force 1, that's what we're trying to find. Now we just plug in the givens. Force 2 is the car's weight, that is 19,620 Newton, times the area 1, that is 0.0081 square meters. All this divided by the area 2, that is 0.2027 square meters. You cancel the square meters with the square meters, and the force 1 is going to be equal to, and we apply the formula, okay? How much did you get?
784.03.
0.03 rounded, and these are Newton. So in other words, this means with only approximately 800 Newton, you can lift a 20,000 Newton car, okay? If it doesn't need to be precise, but just this is the like the purpose of it. With applying almost 800 Newton, you can lift a 2,000 Newton car. I just rounded, okay? Just for you to see the analysis. Just remember, the small force that is applied on the small area should be able to lift an object, a large object, with a large weight applied on the large area. So, in other words, when you are doing the exercise and you don't know if you are sure, at least it makes sense, okay? So, remember this, small force goes in the small area, and the large force goes in the large area, like that, okay? Now, you still don't know if you did it right? You can test. You can check it. How can you check this exercise? Maybe I didn't say this before because I don't think it's necessary, okay? But let's go back to the principle. The main principle says that the pressure 1 is equal to the pressure 2. Guys, are you listening to me?
Yes.
Is that I saw everyone freezed. They just said, oh my God, I don't have internet service. But yes. Okay. So, as I was saying, I don't know if you heard everything, but you can check it. So we're gonna use this part, okay, to be checked. Okay, so you say, again, you say pressure 1 equals pressure 2. Just include now all the information you have. Force 1 divided by the area 1 must be equal to the force 2 divided by the area 2. Just let's plug in the givens that we got, 784.03 Newton divided by the area 1, that is 0.0081 square meters, must be equal to the force 2, that is the car, 19,620 Newton, divided by the other area, that is 0.2027 square meters. Remember, this Newton per square meters and Newton per square meter gives you pascals. Now let's perform these divisions and let's see if it's equal. Well, I got in the first part, in the section 1, I got 96,793.83 pascals. In the other one, I got 96,793.29. So what do you see? What do you think? Is it equal?
More or less. Only the decimal are different, but the
Only
answer.
the decimals are different, as you said, more or less. Okay? So when it's more or less equal, but it's pretty close, we say it's accurate. Okay? So we don't say it's equal. We say, well, not equal, but at least is accurate. So this is going to help us to see if the process that we did was right. Okay? Both numbers are very similar, almost the same. You can get the same answer. I mean, both should be equal. If you get a different answer, it's because of the rounding. Because we are rounding all our answers, okay? So we round the answers and the accuracy is being affected. But in the end, you can see these two numbers are very similar. And if they are very similar, we can say that we did correct. So this is a way to check. So I don't say that it should be the exact same number with the exact same decimals, but this is an idea. Okay, now if for any reason you get here 96,783 and in the other side you get 32,400, for example, in this case is obviously it will be incorrect. Okay, so because the numbers are just too different, but if they are very similar, we can say that we did right. So in your quiz, I will ask you to do this step, okay, to check both parts, to check the pressure in both sections, to make sure that you did it right. Now, this happens a lot when you don't know how to isolate. So by doing this, you will notice, you will realize that you did a mistake and that you have to do a correction. If you have the time, you can do it. Do you have any doubt on this problem? Okay. So for tomorrow, remember this and Pascal, the hydraulic lift, that is Pascal, and continuity equation. If you have any doubt on both, you can ask me today. Later, I'm gonna be sleeping.